All right, here we start section 1.4, and this entire chapter is going to be talking about slope of linear equations. So something hopefully that you do remember from Math 1, here we go. If 2 points are on a line, this point and this point, it's an x1, y1, and an x2, y2, then the rise is blank and the run is blank. So we're going to be using this formula over here to plug in and go 1 minus 7 over the change in x, negative 2 minus negative 5. So 1 minus 7 on the top would give us a run of negative 6. And a rise of down 6, this top part, because our slope is rise over run. And on the bottom, it would turn into negative 2 plus 5. So our run would be 3. So the slope of the line, negative 6 over 3, would reduce down to negative 2. And that's the same thing we're going to do on the next one. Given these 2 points, the rise and the run is this. So let's go do the formula one more time. And we do 9 minus a negative 3 on the top, divided by 12 minus 10 on the bottom. So on the top is 9 minus a negative 3. So that turns into a positive 12. And then the run is 2. 12 minus 10 is just 2. So the reduced slope, 12 over 2, just gives us 6. All right, if 2 points, this one and this one, are on a line, what is the rise over run? Last one. Negative 8 minus 6 on the top. And 8 minus 4 on the bottom. The change in y over the change in x. So the rise is negative 14. And the run, 8 minus 4, is just 4. And this time when we go to reduce this fraction, it stays a fraction because it does not divide evenly. So we would say that the slope is negative 7/2. Okay, so hopefully you remember that formula. In the point slope form of a line, the slope is represented by blank and the coordinate is represented by blank and blank. So here I go. Slope is m in the formula. And the coordinate of the point is your x1 and your y1. So I'm going over here in Cami to the little sub. It helps me put in a sub 1 if you want to. And then y1, y sub 1. If 2 points are on a line, what is the equation of the line in slope intercept form? I'm sorry, in point slope form. So we still need to start with this formula just to get the slope. So we're going to go 3 minus a negative 1. It's going to turn into 3 plus 1 over 13 minus 11. So that gives us 4 over 2, or just 2. So my slope is 2. Now I can go plug into that equation. So y minus y1. So I'm going to always use the same point that I called y1 just to stay consistent with the formula. So y minus a negative 1 equals 2x minus 11. I'm plugging straight into the formula given to us right up here. And that gives me a final answer of y plus 1 is equal to 2x minus 11. And remember that we can write this in the other format of y equals 2 parentheses x minus 11. minus 1 at the end. If I took this plus 1 and subtracted it from both sides, it could end up over there as well. So all of these are good. Could you have written this formula with the other point? Could you have used 13, 3? Absolutely. Y equals 2, x minus 13 plus 3 could have been an answer as well. The equation of the line passing through this point. So here I'm given a formula and I'm being asked to pull out what point would be from this. So I'm going to go ahead and pull out the point 4, comma, negative 3. So 4, negative 3 is embedded in this formula because x minus 4 means it's a positive 4. Y plus 3 means it's a negative 3. Now let's go look. 1, 2, 3, 4, down 3. This point F is on there. So I'm going to go type in point F. Now the slope that we're counting is a negative 1 slope. So if I count that slope backwards, the down 1 over 1, point E is also on the line. The slope-intercept form of a line is y equals mx plus b, where m represents the slope and b represents the beginning or y-intercept of that graph. The m and the b. All right, the equation of the line passing through the point and through this point plotted below the slope is this. So again, we're looking at y equals negative 1/2 x minus 1. So going down 1 and then down 1 over 2. Well, there is no point down 1 and over 2 from there. So the first point, D, is on my line. That's my y-intercept. But now I'm looking to see if I can count the slope backwards, back 2 and up 1, back 2 and up 1. Here's this other point A that would be on my line. So point D and point A are on my line. If the slope of a line is 3 and a point on the line is this, the y-intercept of the line is at these coordinates. So here I go plugging in to the y equals mx plus b, where they gave me a y, negative 2. They told me the m is 3. And then they told me that the x is 1. And I'm trying to find the unknown intercept, b. So I'm going to go 3 times 1 is 3 and subtract it from both sides. And I'm going to get that b equals negative 5. If the point slope form of a line is this, the slope intercept form of the line is, so if I take this point slope form and I simplify it, by adding 6, I get y equals 5 parentheses x plus 3, and I add 6 on the end, and then I'm going to simplify by distributing and adding that 6. 5x plus 15 plus 6, 5x plus 21. So the slope intercept of the line is 0, 21. Graph this line on the coordinate grid below. So I'm going to go put my starting point at 1. Now, before I get started with that, I need to take out my m and my b from this equation. So m is 2/5. My beginning, b is 1. Go ahead and plot that. B is 1. And then from there, I'm going up 2 and over 1, 2, 3, 4, 5. Or I can go down 2 and back 1, 2, 3, 4, 5. And there's my line. The standard form of a line is ax plus by equals c, where a and b represent the coefficients, and c represents the constant term, or the number at the after the equals. When an equation is in standard form, you can easily find the x and y intercepts simply by substituting in 0 for each variable. So this is where Ms. Sanchez says for the x-intercept, the y is 0. For the y-intercept, the x is 0. So here we go doing an actual test for what would the x-intercept be of this line. So for the x-intercept, the y is 0. So first we're going to just write out the equation. 2x, minus 12y equals 3. And in the next step, we're going to make y 0. 2x minus 12 times 0. You're showing that you know the definition of intercept by plugging in that 0. Then we're left with 2x. This zeroes out, equals 3. We divide both sides by 2, and x equals 3 halves. When I'm asked for an intercept, I'm going to write 3 halves, comma, 0 in intercept form. And that's my x-intercept. Now down here, they're going to ask you for the y-intercept. So I'm using this space up here. So same exact steps. We start with the original equation, 2x minus 12y equals 3. This time when I go to plug in the next step, I'm not going to plug in for y equals 0. I'm going to plug in for the y-intercept, the x equals 0. So the plug-in of 0 goes here, showing me that you understand the definition of intercept by plugging in that 0. So that zeroes out. We're left with negative 12y equals 3. We divide both sides by 12, by negative 12, and we get y equals negative 3/12, which simplifies down to negative 1/4. Remember that if they ask me for an intercept, I'm always going to put my answer in intercept form of negative 1/4, comma 0. This equation is that of a, so x equals 9 is my vertical line, and y equals 15 is our horizontal line. A horizontal line has a slope of 0, and a vertical line has a slope that is undefined. Now we're going to list the 4 signs that you guys recall that we use for our inequalities, and we're going to be graphing these, so I just wanted to put a note here. Our less than and our greater than are dashed lines because we are not including the values along the line. And then for a less than, we would be shading down. For a greater than, we'd be shading up. Less than or equal is going to be a solid line. When this inequality sign has a line, it is a solid line. And then we'd be shading down for less than or equal, and we'd be shading up for greater than or equal. So write down these signs again to remind yourselves of when they're dashed and when they're solid and where you shade. And then let's go practice. Looking at this one, I see a y-intercept of 2, and I see that it's dashed and shaded up. So when it's dashed and shaded up, this is going to be a greater than. So going to plug in my inequality equation. I'm going to say y is greater than. My m is up 1 over 1, 2, 3, up 1 over 1, 2, 3. So I'm going to say 1/3 x plus that y-intercept of 2. And there's my inequality. Graph this linear inequality. So here's my b at -1, and here's my slope of down 1 over 1. So at -1, I would start. I'd go down 1 over 1. Now when I'm going to make this one, before I can just arbitrarily draw that line, I need to go up and peek at this. It says less than or equal. So is this a solid or dashed line? And so I'm going to go ahead and decide it. Since it has the line, it is a line. So I am going to make that line a nice solid line. And then I'm going to shade less than that line. And that's the end of our notes.